Hello Unity fans and welcome back to my game development series. We've been stuck on 4 specialist unit types for a few months now while looking into threading, optimization, progressive building and our task queuing system. We've currently got builders, woodcutters, stonemasons and farmers working pretty well. But today it's time to meet a new unit type. In the beginning of the game, this new unit type would basically be a scout, exploring the map so you know in which direction to plan your expansions, and gathering other useful information and even items to kickstart your game. However, as this functionality becomes less important later on, I'd like this unit to apply to higher tier versions of it, so I'm going to call these units Wanderers for now. To me, the most remarkable thing about adding a new unit type to the game is how relatively easy it was, due to so much of the basic functionality of the game being properly designed and implemented in a generic and parameterized way at this point. Let's see what I mean by that. I've spent the last few months really trying to polish, optimize and generalize a lot of the most basic building blocks of the game, developing well-defined subsystems that handle specific functionalities but also integrate well with the other systems in the game. Our builders, woodcutters, stonemasons and farmers are able to perform a substantial amount of work through the automated task system that runs on a parallel thread, while map exploration and fog of war runs on another parallel thread. Finally, terrain triangulation runs on yet another thread. This frees up the main thread to largely perform what cannot be passed on to parallel threads, leading to more and more stable frames per second all around. Another part of the game that I've expanded on a lot during this process is the pathfinding algorithm. And today we're going to add something new and very useful to it. Just like we're able to tell our woodcutters which areas to target for chopping down and planting trees, we also want to enable the player to specify the areas on the map to focus on when exploring. Please ignore the placeholder icons of the UI. I will eventually get decent icons for everything. With the area specified, we now want our wanderer to find the closest unexplored segment to the target area and explore it. So we need to add the ability to test a potential target segment for unexplored neighbors before allowing it as the final destination to the search algorithm. When he gets to the segment, I currently have him put down his basket, wait a while, pick up his basket and get going again. However, I'd probably want to add something more meaningful here, like making some notes and drawings. But for now, let's just keep going. He now looks for the next closest unexplored segment. However, if we always look for the unexplored segment that is strictly the closest to the target area, the wanderer's patterns of exploration would become very unnatural, since he would often walk from his position all across already explored terrain to the other side of the area to get to the unexplored segment that is now the closest to the target area, especially when the player changes the target area. He may then walk across already explored terrain again. Sure, he'd keep exploring in this way, but it would be rather inefficient. We'd much rather he'd walk along the arc where the explored terrain meets the unexplored terrain. This would prevent him from crossing already explored terrain so frequently, and actually gives us a lot more return in terms of area of terrain explored for a slight relaxation of the strictly closest unexplored segment rule. There's another consideration to keep in mind. While the nature of his tasks means he won't visit his home as frequently as the other units, I think we would generally require our wanderer to return to his cabin once in a while. Let's say after he has stopped 6 times to jot down some details and drawings. So we don't want these trips in between stopping to be too short. Otherwise we would stop 6 times in a relatively small area and have to head home without really exploring a substantial part of the map. To accomplish this, we want to tell the search algorithm not to consider hexes that are closer than, say, 4 hexes from the current location. We already have something similar to this, but not as generic, in the search algorithm. Namely, where you are allowed to specify the area a unit should focus on, but penalize the path the further the unit needs to walk from its current location. However, it's more complicated for the wanderer. We still have the requirements of focusing on an area and penalizing the path the further the unit needs to walk from its current location. But now we want to be able to enforce a minimum number of hexes to travel as well, and only let the shortest path outside of that radius be considered. Note that you cannot just block those close hexes as impassable, since the unit still needs to be able to walk on them, just not choose them as the final destination. We need a way to split movement cost of passing through the hex or segment from cost of ending up on the hex or segment. While I already had something implemented for the woodcutter scenario that incorporated two areas and looked for a trade-off in distance between them, I needed to implement something more generic to handle all these possible cases, especially if I want to be able to use this to simplify the addition of future unit types with more complex movement requirements. So I came up with this solution. Whenever looking for a path, you can specify any number of pivot points in a list. For each pivot point, you supply the pivot hex, the inner radius, and an outer radius. Then you supply 3 penalty values. The first one is the penalty per number of hexes away from the pivot hex you are, given that you are inside the inner radius. Actually, we add 1 to this distance, otherwise the penalty gets multiplied by 0 when you're on the pivot hex, which we don't want. The second penalty is for the number of hexes away from the pivot hex, given you are between the inner and outer radius. The third penalty is for the number of hexes away from the pivot hex when you are outside of the outer radius. Let's consider a few examples to show how useful this setup actually is. The basic target area can be accomplished by using 1 pivot hex. In this case, you don't actually need an inner and outer radius, since you just want to get as close as you can to the target area. But our new solution is generic, so we have to set its parameters. We can set the inner and outer radius to anything and set the 3 penalties to the same positive number. So it doesn't matter how far away from the pivot hex you are, the same penalty applies. If you wanted to limit the allowable hexes around the pivot to be considered, you could set the penalty outside of either radius to a very high number. The search algorithm looks for this specific high number as the indicator for allowing a unit to pass on the hex but not settle on it. So you could force the unit to only look inside a set radius. By adding another pivot hex for the unit and playing around with the penalties, you can bias the trade-off between the area and the unit's current location. Now, if we set the penalty inside the inner radius to this high number, we force the unit outside of this inner radius. The penalty between the inner and outer radius is set to a reasonable number, and this lets the unit look for the closest hex outside of the inner radius. This is the scenario we need for our Wanderer's exploration. Again, you can limit the maximum radius outside the pivot hex by setting the final penalty to that very high number. So you only allow the unit to settle within the band between the inner radius and the outer radius. But wait, there's more. If you set these penalties to negative, the unit will try to get as far away from the pivot hex as he can, since each extra hex actually reduces his travel cost in the Pathfinder. This allows you to let units run away from or avoid certain areas. Again, you can limit the outer radius by setting the final penalties equal to the large number. So the unit will run away as far as he can until he hits the invisible barrier of the outer radius. This will surely come in handy later on. But wait, there's even more. If you now specify more than one of these pivot hexes, you can create combinations of desired area limits. If there are 2, 3 or 4 pivot hexes to avoid, specify all of them with their penalties in a list, and the search algorithm will combine all the penalties to find a suitable target location. For now, I think this implementation will be able to handle quite a lot of what will potentially be thrown its way. So I'm quite happy that it works. It may require some tweaking going forward, but it allows us a host of pathfinding functionalities to apply to game scenarios. It certainly works well for our Wanderer's automated exploration. except we run into a little problem. If the terrain elevation is so high that the wanderer cannot actually explore a hex by standing next to it, that hex remains unexplored and repeatedly becomes a target for the pathfinding. The wanderer stubbornly keeps returning to it, wasting time. To solve this issue, we do the following. Whenever a wanderer stops to jot down some details, we check whether any of the neighboring hexes are still unexplored. If so, we allocate the wanderer's vision range to the hex as an unsuccessful vision range. Now, when deciding on unexplored targets, the wanderer only considers hexes with an allocated unsuccessful vision range of less than the wanderer's current vision range. Once the unsuccessful vision range is set, the wanderer won't return to that hex unless he upgrades and his vision range increases as a result. He will then revisit the unsuccessful hexes and try again to reveal them. And that's it for today's video. Please consider subscribing and turning on notifications if you'd like to see more of how World Turtle progresses. Goodbye!